The name is Bond. Atomic Bond. You'd be happy to know that I got that pesky little anion. But our work is not done. Another day, another adventure in bonding. Last time, we figured out why atoms bond, and we began to look at how they bond. Today, we're going to see if you qualify for the bond team, as we probe the mysteries of how atoms bond. I hope you're armed, because you'll certainly need this today. You'll remember that we discussed how ionic substances form crystal lattices due to the lining up of the cations and anions. But we didn't really get into what covalent substances look like. It's a little complicated, so pay attention as I break it down in this intelligence report.
In this lesson, you will draw electron dot diagrams for atoms, draw Lewis structure for molecules, define single, double, and triple covalent bonds, define polyatomic ions, and draw Lewis structures for polyatomic ions.
Let's start with a little review. I want you to look at a periodic table and answer some questions about the element oxygen. Just jot the answers down in your notes. What is oxygen's symbol? What is oxygen's atomic number? How many protons can be found in the nucleus of an oxygen atom? How many electrons are found in an atom of oxygen? What is the electron distribution for oxygen? Let's see how you did. It is important that you don't forget how to find this information using the periodic table. I'm sure all of you know that oxygen's symbol is O. Remember that it is important to use an uppercase O. Oxygen's atomic number is 8, which is, as you should remember, the number of protons and the number of electrons in an atom of oxygen. Did you remember how to write the electron distribution? It is 1s2, 2s2, 2p4. You will remember how we talked about valence electrons, which are the electrons on the outer energy level. Looking at oxygen's electron configuration, you can see that it has electrons on both the first and the second energy levels. This makes the electrons on the second energy level the valence electrons. So oxygen has 2 plus 4, or 6, valence electrons. Valence electrons are the electrons that are involved in chemical bonding. In an ionic bond, these are the electrons that are transferred. And in a covalent bond, these are the electrons that are shared. We have talked about looking at the periodic table to determine how many valence electrons an atom has. Let's review that information, as it is going to be very useful for our lesson today. Group 1 has 1 valence electron. Group 2 has 2 valence electrons. Groups 3 through 12 are the transition metals. You will remember that they can have either 1 or 2 valence electrons. Groups 13 through 18 have 3, 4, 5, 6, 7, and 8 valence electrons. We are going to learn how to represent an atom's valence electrons using dots. Then, we will use these electron dot diagrams to help us get a better view of what happens in a covalent bond.
An electron dot diagram is a way to represent the valence electrons of an atom using the element symbol surrounded by dots. The number of dots is equal to the number of valence electrons.
Let's start with oxygen, since we just remembered that it has 6 valence electrons. Its electron dot diagram would be O surrounded by 6 dots. If you think of an imaginary box around the symbol, you will see how the symbol has 4 sides. We put up to 2 dots on each side. Since oxygen has 6 valence electrons, it gets 6 dots. It does not matter which sides you put the dots on. Now, we will try lithium. First, we look on the periodic table and see that lithium is a member of the alkali metals, group 1, which means it gets 1 valence electron. So, we put 1 dot next to the symbol. Pretty simple, don't you think? Get out your periodic tables so you can practice. Your local teacher will put the list on the board for you to try. When you are ready, I will be back to go over them with you. In the meantime, I'm off to the other side of the world to capture the runaway valence electron.
Local teachers, please pause the tape now and give students time to work problem set 1.
I captured my runaway valence electron. How did your mission go? Check your answers, remembering that it is okay if your dots are not in the exact same place as the ones on the screen. It is only important that you have the same number of dots and that you wrote the symbol correctly. There is perhaps one answer that may have stumped you.
Helium is a member of the noble gas family, so you may have put 8 dots around helium. Remember that helium is element number 2, so there are only 2 electrons to work with. The reason helium is a noble gas is because the first energy level is full with 2 electrons. Now we are going to use our electron dot diagrams to illustrate what happens when a covalent bond forms. The diagrams for our covalent molecules are called Lewis structures.
A Lewis structure is a diagram representing the arrangement of valence electrons in a molecule. The Lewis structure shows the element symbols with dots to represent the valence electrons. A Lewis structure is correct when all of the atoms are stable with full outer energy levels, and the number of valence electrons used matches the number of valence electrons available.
How many electrons does an atom need in its outer energy level to be stable?
Most atoms need 8 electrons in the outer energy level. Hydrogen and helium only have 1 energy level, and they are full with only 2 electrons.
Perfect. You should also remember that the noble gases are already stable because they have a full outer energy level, so they will not be involved in bonding. Let's get started with something simple.
A hydrogen molecule, which consists of 2 hydrogen atoms. Each hydrogen atom has 1 valence electron. There is no way for the atoms to transfer electrons and make both atoms stable. So the atoms are going to share the 2 electrons, which we illustrate by putting a dash in between the H's. This is called a shared pair of electrons. Now both atoms have a full outer energy level, making them stable. We check and see that we have used 2 valence electrons, which matches the 2 that were available. And we have successfully drawn the Lewis structure for a hydrogen molecule.
In a Lewis structure, the dash in between the chemical symbols represent the electrons that are shared by the atoms forming the covalent bond. These electrons are called a shared pair of electrons.
Next, we will draw a Lewis structure for the chlorine molecule, which contains 2 chlorine atoms. Chlorine is in the halogen group, which means that an atom of chlorine would have 7 valence electrons. Since we have 2 chlorine atoms, we have a total of 14 valence electrons to work with. Let's start by putting a pair of electrons in between the 2 chlorine atoms. Then we need to put electrons around the 2 chlorine atoms so that they are both stable. Remember that each one needs to have 8 electrons to be stable. 2, 4, 6, 8, and 2, 4, 6, 8. Both of our chlorine atoms are now stable. We also need to check if we have used the correct total number of valence electrons. 2, 4, 6, 8, 10, 12, 14. We have correctly drawn a Lewis structure for a chlorine molecule because we have used all of the valence electrons available to us, and both atoms are stable. You will notice that this molecule has a shared pair of electrons, but it also has some unshared pairs of electrons. In a Lewis structure, the dots that belong exclusively to one atom represent electrons that are not involved in the covalent bond. These electrons are known as unshared pairs of electrons.
I warned you that you should be armed. Now you've got to use this when your local teacher passes this tape. Your assignment is to draw a Lewis structure for HCl. When you are ready, we will see how you did. M just informed me that the shared paired bandits are at it again. So while I deal with them, you draw.
Local teachers, please pause the tape for students to draw the Lewis structure.
Well, those bandits won't be bonding anytime soon. How did you do? Hydrogen has 1 valence electron and chlorine has 7. If you put 1 pair in between them, you have 6 left to put around your chlorine atom. The shared pair gives hydrogen the required 2 electrons. Chlorine has 2, 4, 6, 8, so it is also stable. Don't forget that we must also check that our total number used matches our total number available. We had 8 to work with, and we used 2, 4, 6, 8, so we're done.
Now, let's try one with more than 2 elements. It works exactly the same, except that we have to figure out which atom is the central atom. There are a few guidelines to follow. It is going to seem tricky at first, but after you practice, finding the central atom will be a piece of cake.
Here are some guidelines that will help you determine the central atom in a molecule. If carbon is present, it is generally the central atom. Hydrogen is never the central atom. The atom with the smallest electronegativity is often the central atom.
So, let's draw the Lewis structure for iodomethane, whose formula is CH3I. First of all, we need to add up our valence electrons. If you look in the periodic table, you see that carbon has 4 valence electrons, hydrogen has 1 valence electron, and iodine has 7 valence electrons. Before you add them up, look at the formula and notice that this molecule has 3 hydrogen atoms. So, 4 plus 3 plus 7 gives us 14 electrons to work with. Next, we have to figure out which atom is the central atom. We look at our guidelines and see that carbon is frequently the central atom. So we put carbon in the middle, surrounded by the other atoms. Now, we draw a dash in between carbon and the other atoms to show the shared pairs of electrons. Then we make sure all of the other atoms are stable. The hydrogen atoms now have 2 valence electrons each, so they look good. The iodine atom is not stable, so we add electrons to give it 2, 4, 6, 8. Finally, we count to see if we have actually used the 14 electrons available to us. 2, 4, 6, 8, 10, 12, 14. We're done. I hope it's getting a little easier for you. Your mission is to try a few more of these problems before we move on. Your local teacher will write them out on the board for you to work. I've got to chase down the central atom that escaped with my latest Bond girl.
Local teachers, please pause the tape now and give students time to work problem set 2.
No central atom is smarter than Bond. I've got my Bond girl back. Now it's time to check your answers. The first one was fairly simple, since it only involved 2 elements. In the second one, the guidelines told you to choose carbon for your central atom. Once that decision was made, it was just a matter of drawing in the dashes and dots. Of course, I'm sure you double-checked each atom's stability, as well as verified that the number of valence electrons used matched the number available. The next one also has carbon as the central atom. This one was a little tricky. Once you put carbon in the middle, you had 5 atoms left. You can only put 4 next to the carbon, but a little bit of trial and error should have gotten you to the right answer. Remember this one because you will often see an H attached to an O that is attached to the central atom. The hint should have helped you with the last one. First, you had to see that you had 6 carbon atoms with 4 valence electrons each, and 12 hydrogen atoms with 1 valence electron each, for a total of 36 electrons. The 6 carbon atoms form a ring with a shared pair of electrons between each set of 2 carbon atoms. You have 12 hydrogen atoms, so you attach 2 to each carbon. Next, you should have checked to see that each atom was stable and that you used the 36 available electrons.
The Prime Minister has requested that you draw the Lewis structure for ethene, which is C2H4. The Prime Minister has requested that I, on the other hand, draw a picture of our latest Bond girl. Let's see who finishes first, shall we?
Local teachers, please pause the tape for students to draw the Lewis structure.
Back so soon. How did you do? Better than me, I hope. I imagine this one stumped you a bit, because it seems that you need more electrons than you have available to make all of the atoms stable. But don't worry. Atomic Bond knows what to do. I'll turn you over to a much more qualified instructor. Let's work this together. First of all, we add up 2 times 4 valence electrons for the carbon atoms and 4 times 1 valence electron for the hydrogen atoms to give us 12 electrons to work with. We know that the 2 carbons have to go in the center because each hydrogen will only bond with one other atom. Now, let's put dashes to show where the shared pairs of electrons are. The 4 hydrogen atoms are now stable, but each of the carbon atoms needs 2 additional electrons. We draw those in, and this is where we run into a problem. 2, 4, 6, 8, 10, 12, 14. But we only had 12 electrons available to work with. Luckily for us, atoms will share more than one pair of electrons when necessary. In this case, the 2 carbon atoms will share 2 pairs of electrons, which we indicate by putting 2 dashes in between the 2 carbon atoms. Now we have 2, 4, 6, 8, 10, 12. And we did it.
When 2 atoms share 1 pair of electrons, the bond is called a single bond. When 2 atoms share 2 pairs of electrons, the bond is called a double bond. When 2 atoms share 3 pairs of electrons, the bond is called a triple bond.
Now, it's your turn. Your local teacher will put these problems up on the board for you to work. So continue your assignment. A triple bond. Well, I like that.
Local teachers, please pause the tape now and give students time to work problem set 3.
The triple bond is complete. And now let's see how your mission played out. After this program is finished, you will be given time to practice more of these. Be sure to get help from your local teacher if you are having trouble, because we're going to build on this in the next program. You're probably starting to notice that many of these molecular compounds contain carbon, making carbon the central atom most of the time. That makes your job a little bit easier. Remember to double-check your answers each time by verifying that the number of valence electrons used equals the number of valence electrons available.
Your next mission for today is to draw Lewis structures for polyatomic ions. You're asking yourself, what is a polyatomic ion? Well, It is a group of atoms with both molecular and ionic characteristics. Within the group of atoms, the atoms are bonded covalently. But when the group of atoms bonds with another atom, it bonds ionically.
A polyatomic ion is a covalently bonded group of atoms with a charge. The charge is what makes the group an ion. If the group has a positive charge, it has one fewer electron than expected. If the group has a negative charge, it has one more electron than expected.
Let's look at an example, and this should make sense to you. The nitrate ion is made of one nitrogen atom and 3 oxygen atoms, and has a charge of -1. Nitrogen has 5 valence electrons, and each oxygen has 6 valence electrons. That gives us a total of 23 valence electrons. The -1 charge tells us that there is 1 extra electron. So, we have 24 electrons to work with. If we follow our guidelines for choosing a central atom, we choose nitrogen because it is not as electronegative as oxygen. So, we put nitrogen in the center, surrounded by the 3 oxygen atoms. We add dashes to represent shared pairs of electrons, since the atoms in a polyatomic ion are bonded covalently. Now, we add dots to make each atom stable. 2, 4, 6, 8 for nitrogen. 2, 4, 6, 8 for the first oxygen. 2, 4, 6, 8 for the second oxygen, and 2, 4, 6, 8 for the final oxygen. Finally, we count up all of the electrons to make sure we have used 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. It looks like we're going to need a double bond. Now we have used only 24 electrons with all of the atoms stable. We did it. With polyatomic ions, we have one final step. We draw brackets around the Lewis structure and indicate the charge of the ion as a superscript. This polyatomic ion will then bond with a positively charged cation. Remember, opposites attract. Your task on this final mission is to draw Lewis structures for these polyatomic ions. Your local teacher will pause the tape while you do this. Then, I will evaluate your work to see if you're ready to join the bond team.
Local teachers, please pause the tape now and give students time to work problem set 4.
Yes. From a first glance, I think you are all ready to join the bond team. Double check your work to be sure. The first Lewis structure is for the polyatomic ion called phosphate. You had 32 electrons to work with, so phosphorus formed a single bond with each oxygen. Make sure you remember the brackets and charge. Our next polyatomic ion is called sulfate. It looks very much like the phosphate ion. Again, you only needed single bonds to use up all the electrons while making all atoms stable. The third one is called the ammonium ion, and it is a little different because it has a positive charge. It is one of the only polyatomic cations. When you added up your electrons, you had 5 for nitrogen and 4 for the hydrogens, which gave you a total of 9. The positive charge means you take 1 electron away, giving you 8 to work with. Once you figured that out, it was easy. The last one is called the cyanide ion. To make this one work, you had to use a triple bond. That way, you only used the 10 electrons available and still made both atoms stable. Your evaluation is almost over. In order to join the bond team, you must first complete the chemistry quiz.
Cumulative review question number 1. What is the name of an atom that has lost electrons, and what charge does it have? A. Cation negative. B. Cation positive. C. Anion negative. D. Anion positive.
Cumulative review question number 2. All of the following are characteristic of ionic compounds except for A. High melting points. B. Easily crushed. C. Strong forces. D. Electrons are transferred.
Number 1. How many valence electrons does an atom of krypton have? A. 2. B. 4. C. 6. D. 8.
Number 2. How many shared pairs of electrons are in ammonia, NH3? A. 1. B. 2. C. 3. D. 4.
Number 3. When two atoms share 3 pairs of electrons, the bond is called A. Single bond, B. Double bond, C. Triple bond.
Number 4. What type of bond forms between the atoms in a polyatomic ion? A. Ionic. B. Covalent. C. Metallic. D. Polyatomic.
And number 5. How many electrons would be available for the Lewis structure for the carbonate ion CO3 2-? A. 20. B. 22. C. 24.
Welcome to the bond team. My work is done here for today, but I leave you with these vital instructions. Keep practicing, so you will be prepared for your next mission. Good day.